In this video, we are going to discuss problem based on impulse momentum theorem. Let us first define what is momentum and impulse. Momentum is denoted by small letter v, which is a product of mass times the velocity of an object. It is a vector quantity. And impulse is defined as a product of force times time. Impulse momentum theorem says that impulse J is equal to the change in momentum of an object. And we are going to use these three rules to solve the problem along with the law of conservation of momentum. Question says a 12-kilogram rock falls from a cliff to the ground directly below. Assume the rock does not bounce. What is the impulse on the rock if its velocity at the moment it strikes the ground is 20 meters per second downward? Let us first write down what the question has given us. You have the mass of the rock m equals 12.0 kilogram. And since it falls from a cliff, when it is falling, initially the speed of the rock will be zero. Whenever anything is dropped or it is falling from a height h, its initial speed we take as zero. When the rock hits the bottom, its speed is 20 meters per second facing downward. So this I will call as my final speed, V final, 20 meters per second. And since the direction of the speed is downward, I will write this as negative. They want us to find what is the impulse on the rock. The basic rule of impulse is force times the time. But here I do not have the force or the time. If you do not have these two quantities, another way of finding impulse is by using impulse momentum theorem. Impulse momentum theorem says that impulse J is equal to the change in momentum of the object. And change in momentum can also be written as final momentum minus the initial momentum. So this final minus initial momentum I can write as m times v final minus m times v initial. And when you take m as common in both, you get m v final minus v initial. So this is the expression for impulse. We have the mass m as 12, v final is negative 20, and v initial is 0. And when you solve this, you get impulse on the rock as negative 240 kg meter per second. So impulse can be calculated using two methods. If they give you the value of force and time, use the rule of the impulse. If they give you the values of initial and final velocity, we use impulse momentum theorem to find the impulse. Question 19. A 35-gram bullet strikes a 5-kilogram stationary piece of lumber and embeds itself in the wood. The piece of lumber and the bullet fly off together at 8.6 meters per second. What was the speed of the bullet before it struck the lumber? Define the bullet and the wood as a system. So let us first sketch our system. Here I have a bullet that approaches a piece of wood. And when it strikes the piece of wood, it is stuck inside it. Then the bullet and the wood move together as one system with a speed of 8.6 meters per second. The mass of the bullet is given as, I will write MB for mass of the bullet, 35 gram. which we will convert to kilogram. Kilogram we divide by 1000. That gives me 0.035 kilogram. Mass of the lumber I will write as ml equals 5 kilogram. The final speed with which the wood and the bullet move, V final, will be 8.6 meter per second. To solve this question, we are going to use the law of conservation of momentum. The law of conservation of momentum says that sum of momentum before collision must be equal to sum of momentum after the collision. So before collision, when I take the sum of the momentum, I need to take momentum of bullet, which I will call PBI initial, and the momentum of the wood, which I will call PBL for lumber. And when I take momentum after the collision, I need to take momentum of this system together, the bullet plus lumber. So I will call this P final. And according to law of conservation of momentum, PB initial plus PL initial must be equal to P final. Now let's substitute. Initial momentum of the bullet will be mass of the bullet times its initial velocity. Initial momentum of the lumber will be mass of the lumber times its initial velocity. Final momentum of the system will be mass of the bullet plus the mass of the lumber, because after collision, they are stuck to each other. And since they are stuck to each other, they are moving together, their mass, I will add them. And let V with the final velocity with which they move. I need to find what is VBI, the initial speed of the bullet. Initially, my lumber was stationary. Stationary means its initial velocity was 0. So velocity of lumber before the collision was 0. When I substitute this as 0, the whole term over here will become 0. And then we can rewrite this expression as mass of the bullet times its velocity initially equals mv plus ml times v final. So we can divide by the mass of the bullet to calculate its velocity. VBI will be equal to mv plus ml over mb times v final. Let us substitute the numbers now. Mass of the bullet is 0.035. For lumber, it is 5 over 0.035 times the speed of the bullet and the lumber together, 8.6. And when you solve this, you get the initial velocity of the bullet to be 1.2 times 10 to the power 3 meter per second. So whenever you have a question like this, we use the law of conservation of momentum to solve it. Law of conservation of momentum says that sum of momentum before collision must be equal to sum of momentum after the collision. And if you have two quantities before the collision, you need to write momentum for both of them. If you had two quantities after the collision, you will write momentum again for both of them. But if the two quantities are stuck together to move as one, I just need to write momentum of the system together. Then you can find whatever quantity is missing by rearranging the terms.